Yeah, so welcome to this talk about distributing support with GDL in C3-Cloud. I'm going to explain GDL in a minute. It stands for Guideline Definition Language. So a few quick words about us. Cambio has been around providing an integrated solution for regions and municipalities. We have a root in electronic health record system to supply big regions and so on. We have a footprint about 170,000 users, mainly in Nordic countries, but also in UK and New Zealand. In Sweden, we supply EHR system and clinical system to 17 out of 21 regions. GDL, in fact, is open air specification. We actually started this journey quite early. I think around 2012, we start to wonder, we're looking for a formal CDS language that can meet our requirement. We started a journey to develop distribution support system for our customer, for our market. And we're looking for a formal language to express clinical logic. It has to be, capable of supporting multiple language and also multiple terminology systems, because we're an international player. We want to supply CDS across different markets. And it has to be based on formal EHR models. We don't like the idea to build rules and logic upon a proprietary model, make it less shareable. We're also very much fond of this idea that the design has to support modular approach. So we can share a piece of model, we can actually reuse and combine this model to support more complex applications. And finally, this is very obvious, the language has to be expressive enough to support clinical logic in narrative guidelines we come across. So this is the list we've been looking, we set out as a requirement, and unfortunately we didn't find existing design in the CDS space in the public domain. So we start looking around and we come across a paper like this one. This particular one is from Professor Alan Rector and his group from Manchester University. The series of papers, this is just one of them. Like many great ideas, it's quite straightforward to explain this. And an essential idea here is that if you want to do distributing support or aggregation computing in the healthcare domain, you really need to deal with at least 3 principal kind of models and build interface around them. And one of them is this information model that deals with instance of patient data, like the blood pressure, the family history, and so on. And you really need to have a way to access this data using queries, using data models. But then you have another one, sometimes we call them slow-moving concept systems. So you have this system of concepts and terminologies, and they're increasingly being standardized by international bodies. Then the last one is so-called inference model, and that's really where it is so-called fast-moving area where we represent knowledge, clinical rules around how to treat heart failure, how to prevent stroke in patients with AF and so on. And that's actually where we design our guideline definition language. Essentially, it gives us our ability to express clinical rules and logic using building blocks from the EHR domain and be able to point into concepts and terms in the reference terminology. So we start the experimentation, we start to work with GDL, and essentially around 2013, we come to a conclusion, since we took lots of inspiration from the open EHR design at the time, namely the archetype design. We use it almost identical metadata model, almost nearly identical expression for the rules. So we come to a conclusion, maybe it's better to release this through the Open Air Foundation. So eventually that happened. This is the particular announcement we made in 2013. Fast forwarding a few years, around 2017 and 2018, a number of things happened. We were invited to participate in the C3-Cloud project due to our Swedish customer region Jämtland, and also we know of some of the research partners in the consortium. We also won a pan-European tender to supply CDS platform in Scottish National CDS program in that period. And also due to the initial implementation of GDL1, we learned a few lessons with our Swedish projects. We start to notice the increased support for H.075 resources in the market. Just give one example, the UK GP Connect initiative was based on 5 resources, and I was recommended to use when we integrate with the GP system in the UK. We also found the design around smart app and CDS hooks very useful. I mean, we are facing essentially the same challenge, so why not use the same design when we do integration? So that triggers a lot of rapid experimentation or rapid development around the GDL2, the language itself, the runtime engine, and eventually the editor and the platform. We go also increasingly towards cloud-based deployment. Let's look at specifically what are we going to do, with the C3-Cloud requirement. You have this concept diagram from one of the C3-Cloud publication. In the middle, it's the CDS modules. Essentially, we're dealing with the risk assessment, stratification, treatment recommendation, sometimes can be detailed treatment goal setting, like a glucose and blood pressure levels, as well as drug treatment choice, even dosing. There are also process-oriented things like automate appointment scheduling, generate referral, generate procedure request, and so on. So it's quite comprehensive, and they're spread into different chronic conditions. And here's a system diagram, again from one of the publications. And here it's really straightforward. I mean, in terms of the C3-Cloud, the CDS services, those are integrated with C3DP, which is the care planning module, where H275 and CDS hooks API. So it's really straightforward. In fact, I think this architecture is much more straightforward than our most CDS projects. Concretely look at what kind of guidelines we're dealing with and how actually know what it takes to model the GDL guidelines in the context of the C3-Cloud. Essentially, we look at this picture. We take CDS specification from some of the partners. In this particular case, it's the distinct trees beautifully produced by our Turkish partner SRDC. And then on the right-hand side is the end result of the GDL guidelines, essentially. A combination of conditions, when statements, and what kind of CDS hooks cards to suggest with detailed suggestions and so on. So it looks pretty straightforward, technical-wise, and it's clear, the requirement-wise is also very straightforward. How difficult it can be. Well, we in fact encountered a number of challenges during the project phase. Because as I mentioned, our period was a rapid experimentation and development. That initially we had a delay of the GDL2 editor, and we were bothered by lots of stability issue and quality issue with the editor that really set us back in the delivery. And because it's so new with the GDL2 design, we lack of training material for the partners, we lack of examples. So we work really hard to overcome these challenges. Then we notice some of the guidelines, they're really complex. They are huge in terms of number of conditions, number of the rules to cover. I think Gauch mentioned in her presentation, we total amount 500 rules in the guidelines we produced. One particular example reached 27,000 lines of code in one piece of GDL2 guideline. That really highlight the kind of challenge we're facing. But fortunately, we persisted. We really worked very hard to achieve these goals, and we managed to successfully deliver GDL2-based guideline CDS service to the project. Here are a few screenshots to show the end result, and this particular example is from INSERM, authored by Jacques, in area of clinical kidney disease and CVD prevention and treatment service. So the first view is showing essentially the keywords, the metadata, the references. And this one show in editor the view of definitions. And here you can define the input data for this particular guideline rules based on 5 resources profiles. Here you have a list of rules within this guideline, and the particular one in focus is about atrial fibrillation management in patients with chronic kidney disease. And here you can see the summary of these cards and the detail and the indicators on the info level. And this shows the terminology bindings in this particular guideline. We're dealing with quite a number of reference terminologies, ATC, different variation of ICD-10, and this particular one is about different SNOMED CT codes. They're bound to the variables that are used in these rules. And the last screenshot is about the execution tab. And this is a very useful feature in the editor. I mean, once you have authored these rules and so on, you can actually test run this. You can capture the test fixture and you can rerun the tests. So this gives instant feedback to the guideline authors, so you can notice what is working, what is not working, and so on. So finally, a list of results, a summary of results. In total, we, together with the partners, we authored 23 GDL guidelines. Some, as I said, are quite massive, totaling around 500 rules, clinical rules within these 23 guidelines. And those cover 4 or 5 areas in clinical medicine: congestive heart failure, kidney disease, depression, type 2 diabetes, and hypertension. And these guidelines are bound to 3 language labels: English, Spanish, and Swedish, because we serve 3 health regions. And we managed to have the terminology bindings in number of reference terminology. And those really take a lot of time to fine tuning the terminology bindings based on feedback from different pilot sites. At least we are aware of at least 6 authors based on the metadata from the guidelines from 3 organizations. It's not just Cambio, but we also have guideline authors from Warwick University as well as INSERM. And all of the GDL guideline resources are published now at GitHub. And I want to take a moment to thank, to express our gratitude towards our partners in the consortium, especially SRDC, Warwick University, and INSERM, where we had really good collaboration. Thanks for your support and patience with us. And finally, there's a team behind this work. We have Matthias, who have been managing the project, Kostas, Inemi, Chemi, who have been working on the modeling side of things, and also developers like Manuel, Ying, and Zhao have been working on the tools, as well as some of the consultants we hired during this period. I think that was the last slide of my presentation. Sarah, back to you.
Thank you very much, Rong, for your presentation.